Okay, so my name is Kimberly Collins, and I want to talk to you all today about SQL and relational databases. A little bit about who I am first. I'm a C#.NET and SQL Server developer. I've been doing that for about 13 years now. I got started by taking a course on Oracle at OCCC 13 years ago, but ever since then I've been working with SQL Server, and my slides just went away. There they are again. I design, develop, maintain databases in SQL Server. I'm currently doing consulting and training. I could talk about this all day long. I'm going to try to keep it to these 20 minutes so Brent has time to speak, but I would love to chat about this more later, or even go into your company and do some training or consulting on your database needs. Just let me know if you're interested in that. So we're going to start by talking about the design of relational databases. I think this fundamental level is important to kind of understand why the database is structured the way it is. If it is a relational database, there are a few things that are true, and there's the pizza right now. We're storing data in tables that relate to each other. A table is going to represent a particular type of entity in your system. Examples are product, person, department, shift, territory. And then each row in the table represents a particular instance of that entity. So a certain product or a particular person. And the columns represent properties or attributes of that entity. So first name, last name, birth date. When we are designing a relational database, the entities are the nouns in the system. So when we're talking to our business side, we're going to be keeping track of the nouns they use. Those are the entities. Those are going to be tables in the system. In a enrollment system, we are talking about students enrolling in classes. In an item order management system, we'll have customers creating orders, orders containing items. So each of these nouns is an entity in the system, and our main goal is to determine how these entities relate to each other. How is one of these, whatever this first thing is, associated with one of those? Can one of these have one or more than one of the second thing, and vice versa? So the principle that's guiding us is called normalization. It's breaking data down and organizing it into tables and columns in that relational database. We're doing this to optimize for data storage efficiency, not necessarily for human readability. I think that's what kind of confuses people when they're new to relational databases, is you look at the data and it's not structured in the way you would like it to be. So we're going to use SQL joins in our queries to do that, and I'll go through that later. But I first want to talk a little bit about normalizing data. Here's an example of some unnormalized data. So if Jess, Brent, and I are taking some classes, we might have this spreadsheet of who's in which class. Very common, like almost required to use students in classes as an example for this. It's like the most common example. So in my spreadsheet, I've got first name, last name, and then the department and course number. I've got myself listed 3 times, and that right away is kind of a flag. Like, it might seem like duplicating data would be a good thing, like more is better, but we want to store each thing exactly one time so that when we update it, we only have to do that one time. If you're storing the same thing in 2 places, well, first of all, are these 3 different people named Kimberly Collins? That could totally be true. Or is this the same person, and when we update a name, for example, do we update it in 3 places? So when we are normalizing data, we are trying to store each thing exactly one time to prevent duplication and update anomalies. Our first step is called first normal form. We're going to have these 5 rules that we need to follow in order to get our data into that form. The first one is that each table needs to represent exactly one entity. So in that example I showed, it was really 3 different things being shown: people and classes and their enrollment in those classes, which might make sense for reports. We will do queries to put this data back together, but when we're storing data in tables, we need each table to be for one entity. Each row needs to be unique. So if you have a setup where a table could have 2 rows that are exactly the same, you're violating first normal form. Each table needs to have a primary key, and that's what we'll use to uniquely identify each row. So if nothing else, you need to have, you can use an auto number, just 1, 2, 3, 4, or some other code that uniquely identifies each row in your table. Rows and columns can be in any order. This is one major difference from a spreadsheet, where people might say, oh, don't change the order of these columns, you'll ruin my spreadsheet. Or don't sort this spreadsheet, you'll mess it up. There might be a logical order to your rows and columns, but if they have to be in a certain order or the whole system falls apart, you're violating first normal form. And then a common setup in a spreadsheet is to have a cell with multiple values, just a comma-separated list of phone numbers or whatever. That violates first normal form. We need to store each one of those values in a separate cell, so to speak. So the different types of entity relationships, one-to-one might seem like a really common one. It actually is not. I'm not going to mention it past this because it's very rare to see, and it doesn't really relate to this way we're structuring data. The 2 examples, or the 2 types of relationships we'll have, are one-to-many and many-to-many. And so knowing which one you're particular relationship is between two entities will help you know how this data is going to be structured. So I'll go through some examples. One-to-many example would be a department has classes. One department can have any number of classes, maybe no classes, exactly one class, or more than one class, and we use the term many to mean just more than one. Because we don't really care. The difference between 2 and 200 and 2,000 doesn't affect this. It's just 0, 1, and many. But the reverse is not true. A class, at least in this system, must belong to exactly one department. We can't have a class outside of any department. We can't have a class shared between two departments. In our example, those need to be 2 separate classes. An example of many-to-many would be those students and classes. One student can have any number of classes, none, one, or more than one. And the reverse is true. One class can have any number of students, none, one, or more than one. So students and classes are the classical example of many-to-many. That relationship between those two entities needs to be represented in our database as a separate entity. So student is an entity, so is class, but then the relationship between those two does have a name. We call that enrollment. So that's what I would call this entity between the two. Sometimes there is no good name, and you'll just combine, it could be student class or class student. But since enrollment is the name that our users are going to use and that our business side would use, that's what we'll call this relationship. So I have taken that data and normalized it. Now I've broken down, instead of just one table or a spreadsheet, we've got 4 going on here. I've put the students in their own table with an ID, and we'd have first name, last name, maybe date of birth, more things. Department has an ID and a name, maybe, actually this would probably be code and a different name. Course would have which department it belongs to, because in this system, a course can only belong to one department. The number, the name, various other columns. But the table here that can be kind of confusing at first is the enrollment table. Here I'm showing that student 1 is in course 1. And if that's all you were looking at here, you'd say, well, so what? I don't know who these people are. I don't know what courses these are. These numbers are sort of meaningless to me. And so in the next section of my talk, I'll go through how we would put this data back together for a query or a report so that this data can be meaningful to us. But keep in mind that normalization is not for us, it's for data storage efficiency. So we'll talk about some joins. And what I just said, normalization separates data into different tables. Usually we're representing entities with IDs, so the student has an ID, the course has an ID, department has an ID, which doesn't mean anything to us. And we're optimizing for data storage efficiency, not for us to be able to read the data. So the purposes of joins, that's when we are taking this data from multiple different tables and putting it back together. We're basically unnormalizing the data. We want to make it human readable for a report or just for our queries. And we want to see information about the entity, not the student ID, but the student's name, not the course ID, but the course code or number or name. I'm going to go through some types of joins. 2 that are very common are inner join and left outer join. Some that are not as common are cross join, right outer join, and full outer join. Some people would put self-join on this list. You can join a table to itself, but you're going to be doing it in one of these ways. So I don't normally like to list that as a separate one, but be aware that self-joins are a thing. The first one I want to go through is cross-join, because I think this shows kind of how joins work, but it's not very common to actually be used. This is returning all the possible combinations of rows between 2 tables. So not likely that you would need this, other than maybe some report wants to see this. You're not probably going to be using this for analysis. If one table has 2 rows in it, for example, and another one has 3, cross-joining them returns all the different 6 combinations. I have used this before for generating test data. I've used it in reports. Otherwise, if you're not sure whether you should be using it, you probably shouldn't. I think that people try to use this, and it's just not the right thing to use. Here is an example of, it was hard to come up with something because we just don't use this, but in the database I'm using, there are sales territories. There are 10 of them. There are 104 vendors. So if I cross-join those 2 tables, I would get the 1,040 possible combinations of every sales territory and every vendor. Not very likely that you'll need this in a query. But to show you the syntax, and this is the first time we've looked at any code in this talk, so I'll go through this a little bit slower, hopefully. When I'm nervous, I speak so fast. I'm going through this way too fast. When we're writing a select statement, generally we maybe just write the word select and then jump down to the from. We're going to start with the from. Purchasing is the name of the schema. Vendor is the name of the table. And I'm choosing to give that a nickname or alias of V. I'm cross-joining to a table called sales territory in the sales schema and giving that an alias of ST. And then my last step, or my next step in writing a query would be to fill in what do I what columns do I want to see this select statement return? And I want to see the name of the vendor and the name of the territory. I'm choosing the names vendor name and territory name. The names in the table are just name. And I wouldn't want to see name and name. I want to identify which is which for me. So I get to choose vendor name and territory name here. And I like to put those at the beginning. You can put them at the end. You can do v.name as vendor name. This is my preference. You can put the commas. Like, it might seem a little weird that my comma is at the beginning of the line. That's just my preference. It could have gone up here at the end of the previous line. I have reasons for doing that I could tell you all about that some other time. So that's cross-join. Nice to know that it's there. It kind of explains the idea of joining tables together, but you're not really going to be using it much. Inner join is much more common. That is where we are matching the rows together on some criteria. We need something to be true to include this matching of rows in our result set. Lots of times, you're going to be joining two tables on a column that exists in both, but not always. You can join on anything. But most often, especially when you're first starting, this is going to be joining on a certain ID over here equals a certain ID over there in the two different tables. Be aware that this can limit our results. Just like we said, some criteria has to be true. It can also introduce repetition because the row in the first table may have several matches in the second table. So if you're not aware of that, you might be surprised to see the data from your first table multiple times, but that's going to be listed for every match in the second table. Just be aware that it can make your result set smaller or introduce repetition that you weren't expecting. The word enter is optional. You can just say join. I would recommend that you type out enter join just to make it clear which join you're using. An example of when I might use this, we have product subcategories, and those relate to product categories. And the product subcategory table has a column called ProductCategoryID, but just showing that our results set, it's going to say 1, 2, 3, 4. We don't know what those are. That's useful or not useful at all to our users. We want to see the name of the product category that exists in the product category table. So we are going to join those two tables together to get the data we need from these two different places. The syntax for that, very similar to the cross join, but we have added a line at the end because we need to tell what we're joining on. This is our criteria that must be true for this match of two rows to be included in the result set. So both of my tables are in the production schema. The first one is called ProductSubcategory. I'm using the alias PSC for that. The second one is called product category. I'm using the alias PC. Some people I know like to use A, B, C, D. Please don't do that. Like, use a name that is meaningful, especially if these start to get pretty long. My personal preference is to use this initials. So I'm joining. We think of these two tables being left and right. The way they're written out here, it's top and bottom, but product subcategory is considered the left one, and product category is the right one. And so I'm joining those two tables on some criteria that's true. Here, the two columns happen to have the same name. They don't have to. The product category ID in product subcategory equals the product category ID in product category. But again, you could be joining on anything. And the last thing I do when I am writing this, so the order is kind of confusing. I would prefer the link syntax goes from first and then select later, and that feels more intuitive. So usually when I write a select statement, I'll just write the word select and then come back and fill in the columns I need. Because I've thought about where I want to get this data from and what I need to join to, and now I'm thinking about, okay, what do I actually want the query to return, which columns? I'd like to see the names of the subcategory and the category. They're both called name in the table. Is there a question? What's your question?
So, at the top, equals would be used sort of like assignment?
I wouldn't think of it as assignment. That I think might mislead you. Subcategory name is just what I am choosing this to be called. So I guess you'd call it assignment. It's alias would be a better term. Yes, down here this is equals. So I've seen, I don't use these a lot, but it is possible to have less than or greater than or not equal. And as you become more advanced, these will become more complex. When you're first starting, yeah, I'm looking at these two product category IDs have to be equal. That's my criteria. And yeah, you could think of this as equal as being an assignment. Subcategory name is an alias for PSC name, just like PSC is an alias for product subcategory. So these are, if you want to put spaces in there, you'll need to do brackets around these, but my preference for the format would be whatever name I want my report to use equals, and then my alias of the table dot column name in the table. And so here's another one. I like to put my commas first. That's just me. What's your question? Not important here. I forgot to repeat the question. That's so hard to remember to do. In this join, it's not important. In the next one, it will be. So just to be aware that when we say left and right, we mean first and second. So soon that will make a difference, but in inner join, it doesn't really. Good question. Left outer join. So here now we're talking about left and right. Left outer join is very common, just like inner join is. But here we want to see all the rows in the first table, even if they don't have a match in the second. So in inner join, they had to have a match in that second table or we're not going to include them. Here, the first table is important to us to see everything. And then the second is almost like an FYI. Like, if there's something there, show me. If there's not, that's okay too, just show null. And again, you may be confused by repetition that you see because the first table may have multiple matches of the second table. The word outer is optional. I personally kind of go back and forth between just left join or left outer join. It's probably better to be more explicit, but there's no difference between left join and left outer join. Another way you can use left outer join, and this starts to get a little more complicated, but I do see this used pretty often, so I want to mention it. You can use a where clause to limit your results. Is there a question? Oh, I have 5 minutes, okay. I was worried that I was going too fast, so I slowed down. I'm going to have to speed up again. A where clause is where you are limiting your results. You can use that with a left outer join to only get the records in the first table that don't have a match in the second. So show me all the things over here that don't have a match over there. A couple examples of left join. I want to see all the products and their subcategory if they have one, but if they don't have one, that's okay, just show null. Or I want to see all the products that have never been sold. So I'm going to get all the products, but I'm going to use a where clause to limit those to only the ones that have not been sold. The first example, I am joining the product table to the product subcategory table. That's a left join. Left indicating I want to see the products regardless. That's the left side of this. The other side is the product subcategory that show it if there is one. If there's not one, just show null. The example of a where, so the where goes down here, that limits our result set. I am joining the product table P to sales order detail. That's where they keep track of every time a product is sold. I'm aliasing that as SOD. The product ID is the column that's in both. That's my criteria that I need to match. But now I'm using a where to only show the ones where the product ID is null. There is no match. I'm not including any columns from SOD because they would be null anyway. There's no reason to show them here. But this gives me a list of products that have never been sold. Right outer join, you could do this same query the other way around. I have personally never done that. I see this very rarely. I'd be willing to say you just don't need this, but be aware that it's there. You could structure this the other way around, and it's analogous to left outer join. Full outer join I do use somewhat often in reports. This is like the left join where I want everything from the first table even if it doesn't have a match in the second, but also vice versa. I want all the tables from the second table even if they don't have a match in the first. So that's what makes this full. I want to see what an inner join would show me and the left join and the right join. I want to see the full join between these two tables. An example, in this database, salespeople are assigned to territories. Each person has at most one territory. Some people don't have any territories, and some territories don't have any salespeople. If I only wanted to show the relationship between salespeople and territories, I would use inner join. If I also wanted to include the people who don't have territories, I would use left join. But since I also want the territories without salespeople, I'm going to use a full join between these two tables. The syntax for that is the same as what we've been looking at. By the way, the salesperson table didn't have exactly what I needed, so you can assume this is a CTE. If you're not familiar with common table expressions, look them up. I love them, but it's too much for this talk. Just be aware that CTEs are super useful, and I love them. I'm full joining salesperson to sales territory. Territory ID is in both. Name is in both, but the name of the first one I want to call salesperson name, and the name of the second one I want to call territory name. This is what the data might look like when I get it back. Jillian is assigned to the central territory. Linda has Southwest. Rachel doesn't have one. And Alaska doesn't have a salesperson. But I want to see every territory, whether it has a salesperson or not, and vice versa. I want to see every salesperson, whether they have a territory or not. So back to that list, I'm just going to go ahead and cross right outer join off. If you want to use it, great. I don't. Inner join and left outer join are very common. If you're just getting started, those are probably the ones you need. Cross join is probably not what you need, but it is there. And then full outer join, maybe if you're doing reports, you would need the things from both tables, even if there are no matches. Some resources if you want to learn more. The way to get started is to install SQL Server Management Studio. You can just Google that and find instructions. I also have a tool I like to use called LINQPad. I did a talk on that. It's a little bit more lightweight, a little less intimidating if you're just getting started. So I'm most of the time going to be in one or the other of those two tools. A lot of the examples I used today are from the AdventureWorks sample database from Microsoft. So here's a link to install that, or go Google it to find instructions. If you want to learn more, Techlahoma has had several talks on SQL. Brent did one. Brandon did one, sorry. I've done a couple. On my GitHub, I have some code samples. There's also a SQL group here in Oklahoma City. We meet on the third Monday evening of the month, so same day as analytics. We'll be back here tonight at 6 o'clock. If you want to actually get some hands-on practice with designing a relational database, our AV automation team is currently working on designing a database, and we'd love some help. And that would kind of give you some practice with these one-to-many and many relationships, also with writing some queries. If you're interested in getting involved with our broadcasting at all, let me know. I'm the chair of that committee. I'd love to get your help with that. If you have any questions, I'm right at time, so I probably won't take any unless there's some quick ones. The best place to ask these questions are in Slack. Techlahoma has a Slack. If you're not in that already, sign up at slack.techlahoma.org. We have channels for databases and for OKC SQL. If you want to contact me personally, it's just my name, @Kimberly Collins, and I'd love to get your questions there. Are there any quick questions right now? No? Okay, gonna hand it off.